Hi everybody, welcome to my YouTube channel. Imagine using an AI application on production only to discover that your model is generating answers that sound completely confident but are completely wrong. That's called AI hallucination, and it's one of the fastest ways to lose user trust and is one of the biggest challenges when building AI systems. In this video, I'll show you 15 enterprise proven prompt engineering techniques that can dramatically reduce hallucinations, improve LLM accuracy, optimize token usage. You'll learn everything from zero shot, one shot, few shot prompting, Q prompting to very advanced strategies like temperature tuning for reducing hallucinations, top P tuning, space efficient prompting techniques, and optimizing token utilization without sacrificing the quality that are currently used in the real world AI applications. And one of these techniques alone can often improve output quality and help you build more reliable generative AI applications without changing any AI model or doing any fine tuning or without even increasing the infrastructure costs. So, if you are dealing with LLMs and generative AI, this is a video you will want to watch until the end. If you're dealing with any AI systems and want to keep learning more about them, please subscribe to my YouTube channel and please like, share, and comment on this YouTube video. Alright, let's begin. Most prompt engineering tutorials teach you how to write better prompts, but they rarely uh, rarely explain how to reduce LLM hallucinations in production AI systems. So let's start our course and address the issue. So first thing, how the quality of the prompt or the instruction affects the quality of the AI output, right? So think of like you as a human, that AI, that LLM model is a human. When you're giving some directions to a person, right? So like if you give a simple instruction, right, then person has to guess many details. Like when you go to a restaurant, you just say, give me a drink. So the waiter doesn't know, right, which drink to give. Then what will be the result? A random drink. They'll just give it a try and give you a random drink. So when you will give a detailed instruction, so then the person knows exactly what you want and give a better result. You can say, oh, I want uh, hot coffee, right? Or a cold coffee with these and these ingredients, all of these things. You can give all the details and then you'll get your correct coffee. So it's same thing with the AI, right? If you'll give simple instruction, it'll hallucinate and it'll just give you a random result. And when you'll give a detailed, complex instruction with bullet points, more context, it'll do less hallucinations and it'll give you better results. But not only that, AI is not human, right? So there are some strategies that you're going to learn in this video that will result in less hallucinations. So just to begin with, if you're a beginner, so as I've only just gone over this, the prompt for the drink. So this can be the prompt for the drink that you say, act as a nutrition assistant. I want you to recommend one healthy drink, follow these rules, and but is this the best prompt for your complex enterprise systems? No, definitely not. There are many things to learn that we are gonna learn, right? So the key lesson from this point is that the more specific and structured your instructions are, the better AI can follow them. So we are going to discuss the real production scenario in this video, which will be a rule validation system. So every day, banks, for example, they update approval policies in a CSV file. Like there is a loan system, right? Everybody once or a while they have applied for a loan, and bank has a let's say CSV file of their dynamic rules, which keep on changing. And so let's say they have rule ID and the condition is applicant age is if less than 18 years and they're applying for a loan, reject their loan. And if their credit score is less than 600, let's say, reject their loan. And similarly, if existing debt already they have greater than 50% of their income, reject their loan. Similarly, employment length, if they have just worked for less than 6 months, reject their loan. If similarly, there can be more XYZ rules, so otherwise approve. I have just kept these 6 rules, right? For now, let's say they're just 6 basic rules. And CSV is loaded at the runtime, so the AI doesn't know the rules beforehand. So for your bank loan approval scenario, LLM doesn't know the loan rules in advance. Your application reads the CSV at the runtime, injects these rules into the prompt before sending it to, let's say, in this video, I'm gonna take example of Azure OpenAI LLM model, but there are many models like Claude or other models that are available. But I'm just for the sake of this will work with all kind of models, right? This structure, these problems, these improvements that I'm gonna address. It's just for example's sake, I'm taking bank loan approval scenario with this model, let's say. So first technique, we'll start with the most basic one and we'll go with the more complex things and more detailed and advanced concepts to reduce hallucinations in this video. So first thing is zero shot prompt. Zero shot prompt means zero examples provided, only instructions and runtime rules are provided. You know that we need to provide 2 different kind of prompts. One is a system prompt where you can say you're a bank loan approval assistant. So you have given the context, and then you can say follow the loan approval rules provided by the user and return only decision this or this, include a short reason. And you haven't given any examples. And in the user prompt, dynamically your application is sending all the rules, and then they're also sending the applicant details like this: name John, age 30, all these things, right? Whatever data. So then that LLM consider both system prompt, and for the applicant and the rule data, it will check user prompt, and then it will call, let's say, chat completions API, and then we'll have the expected output. This is the output our LLM will give, right? Something like that. But this is not that good. This is good only for basic systems, but for enterprise systems, this works very less time because enterprise systems are very complex, right? So here, so then we should mostly go with either one shot prompt or few shot prompt. So what is a one shot prompt? That means we provide only one example so the model understand exactly how to apply rules. So let's say I'm giving you a bank loan approval assistant. Use the provided rules by the user to determine the approval. And you can provide here example, right? Okay, that example is, if these are the rules, this is in the system prompt itself, you are giving one example, random example, that these are the rules, this is the applicant information, and this is the decision, this is the output, reject, something like that you're given, and then you're giving the reason as well in the output. So, and then you're sending the actual user prompt, all the applied rules and applicant data, and then you will get this example result by the LLM. So like I have just used here example user example assistant here. You need not use these words in the prompt itself. Those labels are typically used in documentation to explain the concept. In actual Azure OpenAI chat completions, examples are usually represented as separate messages with the roles, right? That this is a system role, this is a system prompt, this is a role is user, this is user prompt, and this is assistant, which is, and then this is your assistant results, right? The prompt. Okay, so So model is learning from the pattern of the conversation. So now what makes a good one-shot example? The decision logic. Show how rules are evaluated. Model learns, check every rule and explain the failed rule. So you don't have to just show, that this, if this is the input, give that output. You have to teach that how to evaluate all the rules and how to explain the failed rule. So, and also one more thing. So there are some improvements that you can do here, right? So one is the decision logic. Don't directly give the decision logic, give them the evaluation examples, and then give a response format. So for example, generally it's seen that JSON or some structured output works well with the prompts and the AI LLMs. So for example, if you want a JSON, show JSON for output in the system prompt. The model will often continue producing the same structure when returning the output. So in the system prompt, right, where you were giving example in the output section, give some JSON format, right? If you're engineer, I think so you already know what is a JSON format. If not, it's just in curly braces you write keys and value pair. So this is a key is a decision in a quotes colon, and then its value, reject for example, or approve, right? And then reasons you can give here either just the value in the quotes, or if you want multiple reasons, then it can be an array. Whatever JSON format you want to give, you can give that output example in the one shot example in the system prompt. And also then, so one way to improve, right, a good one shot example is the third way is edge cases. So for loan approval, right, examples should demonstrate common scenarios. For example, edge case can be age is 19, right? So credit score is 750. So here decision, it's saying reject. Actually, age is, here it should say 17, right? Sorry. So this is a hallucination actually. So that age is 17, but credit score is 750. So credit score is good, but age is less than 18, right? So here the age, what will you'll show in the prompt? Okay, the decision will be reject because reason is age requirement not satisfied. Instead of this, right, as I mentioned, if you will use this JSON format, it's better, right? But in this way, it will learn, okay, this is a single rule failure example. And then example B can be multiple rule failure, where both of the things like age is less than 18 and credit score is 650, this is reject, and it is giving two reasons. One, age requirement not satisfied. Second one, credit score requirement not satisfied. So this teaches the model to report all violations, right? So these are some of the things that you can consider to improve the one-shot example: evaluation, response format, and give the edge cases. Okay. Now the best pattern for your loan approval scenario. Since the rules are dynamic, they are coming from the CSV. Instead, teach a generic evaluation pattern I was saying right above. So what you'll say is you're a bank loan approval assistant. Evaluate the applicant against all the provided rules. And then you'll give some rules like every rule must be satisfied. If any rule fails, reject the application. Return all the failed rules with the reasons, right? Something like that. And output JSON only. That's also, you can give instruction in this format, right? Like decision, approve, reject, reasons in an array. Then you can give some one-shot example. This is the rules, this is applicant, and this is the decision in a JSON. So model can now generalize because it learned the pattern that you have to check the rules, check the application, list the violations, and make a decision. So this is a effective pattern. So system prompt is having the instructions, as well as it's having the output format, as well as it's having the example, right? In few short examples we'll give multiple examples, right? So it'll have um, sorry, in system prompt only it has instruction, output format, and you can give few short examples. And then in a few short example you're giving the rule list, applicant, and the decision. Okay. And in the runtime user prompt you are giving today's CSV rules and the applicant details. So this is what works well for this example. This keeps the model focused on evaluation process rather than memorizing specific loan rules, because rules can be many kind of different rules, they can be updated, all those things. Now I'll go over the few short prompt, which is multiple, giving the multiple examples to LLM to teach the consistent behavior. So here system prompt, as I mentioned, can be same. You're giving one example. Here is example 2, example 3, all those things, right? And then you're giving the actual runtime user prompt, and then this is the output coming back. So it's just difference between one shot and few shot is giving one example versus giving multiple examples. Okay, coming to now Q prompting. Q is a starting pattern that guides the model's output format. For example, when you're giving some here prompt, right? And at the end, for example, here you're giving rules. These are the rules. This is the applicant. And at the end, you can just leave it like decision, right? So what is this saying? So this is queuing in the user prompt that your output should start in this format. Okay, so this is the queue. Decision is the queue. This nudges the model to continue in this some expected format. So the expected outcome will be, it'll start from the decision. So now where the few shot helps, if the rules become complex, right, like rule 1 to rule 10 changing daily, or they are getting complex, adding 2 to 5 examples of approve and reject decision in the prompt can significantly improve consistency, because the model learns the exact interpretation and response format before evaluating the current applicant. Few shot prompting and Q prompting, they're often used together, right? But they solve different kind of problems. Think of it this way, that few shot prompting is show me examples. You teach the model how to perform the task by giving example, like you give kids, right, different example, you show them with different examples and they learn from the behavior. So model learns how to evaluate rules, how to decide the decision, and how to explain the reasons. Q prompting is start the answer in this way. It's not teaching the logic, it's just starting, right? So what few shot does that Q cannot? Few shot examples help teach these special business rules. Now the model understands the exceptions. Q alone cannot teach any logic. Few shot prompting is much more effective at reducing hallucinations. Q affects just formatting, not the reasoning. So for modern LLMs, right, like GPT 4.x, now there are GPT 5.x, right, in the market. There is Claude 4, Gemini 2.5, etc. All the modern LLMs, structured inputs and structured outputs generally better perform than the free from text for the business workflows, especially like these enterprise workflows like loan approvals. So the reason is not that AI is not good at reading text, but it is like it likes JSON. It's like JSON reduces the ambiguity, right? It's a, oh, this is a key, this is a value. So it's specific, right? So instead of just giving like age is greater than this is greater than this is applicant, directly giving in a free text form, you give some JSON. Okay, like this, that input is rules, field is age, operator is this, value is this, fill is this, all of this, applicant is this, right? So it will understand this thing better than this thing. So modern recommendation, right, for this kind of enterprise production level systems, the best recommendation to reduce hallucination is in the system prompt define behavior, give few short example, teach reasoning, but give those example in a structured runtime input and structured output schema. It will force the consistency, and you can give optional cue to nudge towards the desired format. So this is what the basic things we have learned, but in further video you'll learn about the advanced strategies. Okay, so this is closer to what production systems do. So if your goal is to maximize consistency and reduce hallucinations, you can put few short example directly inside the system prompt. Many production teams do exactly like this, adding the few short examples because they teach the model the evaluation pattern. But cue prompting is little less important if you're already forcing the JSON input and JSON output. So you can just avoid the cue prompting technique. You can still include JSON starter as a cue, right? That in a JSON format. So the prompt is your bank loan approval design engine. Your task is to evaluate application using only the rules applied in the user input. You'll give some instructions like do not create or ignore any existing rules, evaluate rule against applicant, approve only if all rules are satisfied, reject if any rule is not satisfied. You have to mention all these things, right? And then you're giving the instructions at the top in the bullet points, and you're saying if information required to evaluate rule is missing, reject the application. Do not use any external knowledge or assumptions. If rule is ambiguous, interpret it exactly as written. Return a valid JSON only. Keep the reason under these many words, because nowadays LLMs, they are generating and consuming so many tokens, which is increasing the cost of AI consumption as well. So these things, right? So to avoid hallucinations, there are quite a good pointers I have highlighted here. Like approve only if all rules are satisfied, reject if any rule is not satisfied, and if information is missing, reject the application. So this is the edge rule you are highlighting. Do not use any external information or assumption, because sometimes in hallucinations it uses its own brain and kind of use external knowledge and assume. That reduces the consistency of the production environments. And also we have to mention that return a valid JSON only. And we have to also let them know that, because else nowadays what we have seen with the newer models is that they keep on increasing the tokens and generating the reasons, talking a lot of words. So you just give me the summary of the reason under 100 words. So this will keep your token utilization and the cost under control as well. And you will, after giving all these instructions, right, you will give example of the input in a JSON format, JSON rules in an array, that this is the rules, this is the applicant information, and output, this is the output JSON. You will give second example where in the first example, one rule not satisfied, two rules not satisfied, give example. So all these kind of things. And then here you're giving a queue again, that for every request return JSON in exactly this structure, right? You are highlighting the output format, and here you're giving the queue again, response JSON decision, like this. Okay, now why this works, technique, why this is the best prompt till this section of our video is because you're using few short example, teaching the model how to evaluate rules and generate the decision. You're giving the cue in a JSON format. So, it will you're nudging the model towards responding in a JSON format, and you're giving instructions where you are telling the model to prevent any assumptions and hallucinated rules. Okay. And your Python code will, send the user message in same format in a JSON as well. So this is kind of practical pattern used often for different kind of models like Azure OpenAI. All right. So which performs better? In modern models, ranking is usually structured input plus output schema enforcement that we have done above is the best. Many APIs now support JSON schemas / structured outputs directly. Second best is structured input and the few short examples. And third best is structured input, structured output, few short example, and queue. That's what we have mentioned, all of these things, right? All right. And what is the lowest reliability that most of the people are making mistakes is natural language only. So that's the lowest reliability of the prompts with the AI models. Like giving, age should be over 21, cred should be above this. So this is the natural language, which is the lowest reliability for the AI. It's not human, right? It though understands it, but sometimes it's like, I'm not human, right? I am AI model. So it's kind of hallucinates there. Because wording variations, they can introduce ambiguity. All right. So now, further, I'm gonna give you some tips, advanced techniques for the newest models, right? That how do several strategies, right? We'll quickly go over more advanced strategies that will make your prompt robust. It will reduce the hallucinations with your AI models, and it will let you earn the trust of your users back, because you will see 100% accuracy in your production systems. So first thing, supporting content. The rules are not the main task. They are supporting information, right? Used to make the decision. Give examples before the actual applicant that, we have already shown you. So the rules you are sending, that's the supporting content, right? That you are sending in the user prompt. So you should always do that. Clear instructions. Put the task first prior to the examples. Supporting content and user data from only you keep in the user prompt. So break the task down into the steps. So I haven't shown you in the instructions that how to break your task down into steps. So that's a good strategy for giving the clear instructions to the AI models. Ask the model to do the task in order of steps mentioned in the prompt. Okay, and then repeat the instructions at the end. That's a double down strategy. So this is useful when prompts become very large. So LLM always give importance to the instructions at the beginning. So when they become large, sometimes you have to go with a double down strategy. So give instruction before and after your primary content. Use an instruction queue, so on, right? And repeat them, highlight them again in the long prompts. So clear syntax. Use separators and sections in the prompt. For example, when you were giving rules, right? So you can use like triple hash or the new line strategy, or you can use some syntax. So let's say, what I prefer is I use when I'm giving example, like this is the input. I use to start every new section or a paragraph in a prompt, I use triple hashes. You can use some kind of separators or to just highlight different kind of sections. Like now these are the new examples starting example 1, right? this is the input, this is the output. So they can be using different kind of separators to define different kind of sections, which will help in kind of understanding clear syntax for the AI models. And then give the model an out strategy. So what's this strategy? Like insufficient data for missing information, right? So it can sometimes be helpful to give the model an alternative path if it is unable to complete the assigned task. So what is the out for the model in that scenario? For example, when asking a question over the piece of text, you might include something like respond with not found if the answer isn't present. So this addition can help the model avoid generating false response. So you can say if you are not able to understand the rule or the information is missing, don't approve, instead reject the application and return the reason as insufficient data, something like that. So you have to highlight in the prompt given example and give the model an out. What happens then? Rather than just giving it a guess and letting the model hallucinate on its own. So this is a very important thing, to always give the model an out in the system prompt. Then the order matters. Order in which you present the information to the model might impact your output. Whether you put instructions before your content, summarize the following, or after, right? Like summarize the above, can make a huge difference in the output. So even the order of few short examples can matter. This difference is referred to as recency bias. So you have to see what is more important has to be on the top. Okay, and then output structure. That's very common strategy used in enterprise systems nowadays. So as I already mentioned, that LLMs, they are good with structured inputs and outputs. So always have a structure for your output and mention that in your system prompt. And even for the user prompt, use some structure. Use of affordances, like you need not mention all the rules in the prompts itself, like I just showed. Use some external, instead of relying on the model memory in the prompt, system prompt, provide external data like CSV we were using, right? From the CSV file, we are reading the rules and inserting the required rules into the prompt, and then we are sending to Azure OpenAI model. So that's how you have to use this strategy. And then there is a chain of thought style. So it's used for non-reasoning models. Ask for step-by-step evaluation and reasoning. For example, evaluate the applicant and the rules step by step, or you can say show rule evaluation and then the final decision. But always give, as I mentioned nowadays, the length, that the restriction, that give the summary or the reasoning in these many words. So that's more important, to have a control over the token generation and the cost consumed by the AI agents. So next things are temperature and top P parameters, and space efficiency and token utilization. But before going over these things, the strategies that we have used, I have mentioned here. I'll show an example using all of these strategy for the bank loan system example that we are using in this video. So the system prompt will say, your bank loan approval assistant, and see, you have started a new section like ### task. And then you're giving in a steps, the instructions, right? Step 1, check each rule. Step 2, state whether each rule passed. Step 3, return, final, approve or reject. And then you're giving some common instructions. Follow the provided rules exactly. Do not create your own rules. If any required instruction is missing, return the insufficient data. So this is an out. And here you're saying, defining the output format, structured output, return JSON only in the format decision, these things, and then failed rules. Okay. And then you're giving some examples, right, as well of the output if you want to give decision, failed rules, right, rule 1, rule 2 if you want to give. And then you're giving few short examples, like example 1 here you're giving, okay, this section is related to rules, this is applicant, this is output. Okay, so you're using separators here. Okay, and example 2 you're giving, and so on, that I have already explained above, that how to give different kind of examples in different JSON formats. And as I mentioned, repeating the instruction, if your prompt is becoming long, you are repeating at the top end important, repeating the important instructions at the end. And for example, return only, approve or reject, something like that, right? I'm just giving example. So that's how what I explained in these strategies. I have just demoed it in that prompt example. This will help you reduce the LLM hallucinations, right? And you will reach near to 100% accuracy using these kind of prompting strategies. Okay, so these were all of the prompting strategies that you could use to reduce the AI hallucinations. Now, except for prompt strategies, there are these things that I mentioned that can also help you reduce AI hallucinations. So, what are these? Let's go over that. All right. Temperature and top P parameters. Changing the temperature, right, when you're, for example, making chat completions API call, with respect to, for example, let's say, is your OpenAI model, or there can be other API that you're, already exposed by the AI. If you're already worked with LLMs and AI calls, there are APIs and they have these two parameters when calling the API, which is called temperature and top P parameters, right? So changing the temperature parameter changes the output of the model. So the temperature parameter can be set between 0 and 2. Higher the value, for example, 0.7 makes the output more random and produce more divergent responses, while the lower value like 0.2 makes the output more focused and concrete. So for example, if you have to generate a fictional story, you will keep the value higher of the temperature, right? Because it will be creative. But for rule validation systems where you don't want the model to be creative, instead you want it to be consistent and focused, you will keep your value very low. All right, and top probability, that's the top P parameter. This is another parameter similar to temperature, in that it also controls the randomness of the model response, but it does so in a different way. The general recommendation is to only alter one of these two parameters. Don't change the values at the same time, because then you will not be able to, see how the impact of changing both parameters, that how AI model is behaving. So always change only one parameter, either top probability or the temperature. So for example, for here, right, for our loan example that we are giving, we should keep the temperature lower. In your API settings, keep your temperature to 0.1 to 0.2, right? Keep the temperature low, because why? The model follows the rules very strictly and consistently. We want consistency in these kind of systems. So if you'll keep the API setting to higher temperature, like 0.8 or 0.9 or something, whatever, right, then same prompt will give different kind of possible outcomes, A or B or C, and we don't want that. It is for more variations in wordings and the format, and for loan approvals, this inconsistency is usually undesirable. We don't want it to hallucinate more, right? Okay, so the recommended temperature for this kind of bank loan, in banking, it will be either 0, right, or 0.1, so that it can be the most deterministic responses. Top P example, Also, same thing. The model only consider most likely outputs with the lower values and different possible outcomes with the higher values of the top p parameters. So the best practice is use either this, keep the temperature 0, top p 1, or keep temperature 0.1, top v1, or avoid changing both together, right? Don't, like, bad example is you're reducing this as well, you're playing around and reducing this as well. So then if both are changed, it becomes harder to predict the model's behavior. Okay, now so great, you have really learned lots of strategies here in this video, and I hope this will help you, reduce hallucination. Just before going to the next topic, which is space efficiency, I want you to comment and share with me which of these strategies you were already using while interacting with AI models in your prompting, and which of the techniques you are interested in using, and or when you will implement in the project, let me know which of the strategies helped you most. And also please comment and help others and me know if there is more strategies that you are aware of and that helps in reducing the hallucinations in the production enterprise systems. All right, now going to the next topic, which is a space efficiency example for the same loan scenario. Suppose your CSV contains 100 rules, right? And you're giving an example like applicant name John, applicant age this, right? So there are lots of repeated words, there are spaces, lots of spaces, there are lots of new lines, right? So these new lines, repeated field names, they consume extra tokens. So these are very less efficient. So most efficient is either use the table format, because AI models are good with understanding the table formats. Even more efficient is like JSON I mentioned, right? Give it in some this way. So you're not having new lines, you're not having white spaces. So this is very compact and token efficient. So if you're giving, like this rule, so there are so many white space examples, so there are extra blank lines, they consume additional tokens. Better is this, you're not using any additional tokens with this. So summary for the banking applications that we have been using: temperature 0 to 0.2, top p parameter keep at 1, output format use the JSON, rules you, instead of mentioning in the prompt, keep it in the runtime CSV, prompt style structured, first rules, with examples like rules applicant output format, space optimization, use tables or compact key value pairs, and avoid excessive white space, long explanations, or high temperatures, and give the limit, right? Give the reasoning within these many words. So I think so all these strategies will help you in your production systems. And if so, don't forget, if you want to keep learning about AI models, more strategies, all the latest technology related to AI models, LLMs, system designs, and other things, or if there is any other topic you want me to make video on and explain on, please comment, and please subscribe to my YouTube channel so that I can keep uploading more videos on this YouTube channel. Thank you.